All right, checking this one out. This is a fairly simple one because there is no number in front of x. So you don't have to multiply the x values by anything. And there's no number in front here, so you don't have to multiply the y value by anything. So what you're gonna simply do, there's two transformations. You're gonna take the parent function, y equals the square root of x, and you have your x and your y, and really this is good enough. Whoops, 0, 1, 2, 3. And what are they asking you to do with this? What's the first operation you're gonna do? You're gonna take your x value and do what with it? Add 3. So what did you get when you added 3? Can I hear the numbers going down? Add 3 to all these, what'd you get?
3, 4, shade, 4.
Good. You keep your y's the same, right? What would be the next operation? You're gonna take your y values and add 2. And what did you get for y's?
2, 3, 4.
So graphing this over 3 up 2. Over 3. 1, 2, 3 and up 2. And then over 4 up 3. Over 7. And up 4, and over 7, 8, 9, 10, 11, 12, and up 5. Is that what you guys got?
Yes.
Okay, hopefully I counted my boxes right. Can you tell me the domain and the range now?
Actually, it's greater or equal to 3. One is greater than equal to 2.
Very good. Now, if I ask you to find the inverse of this, would everyone be able to do it?
Yes.
You would flip these, I would just do the first 3 points, flip them. So in other words, instead of graphing 3, 2, you'd graph 2, 3, 3, 4, 4, 7, and 5, 12, okay? Then what you would do is take this equation and swap, put an x here and a y here. So you bring this over and then square it so you can get your, do you want me to do that real quick for you? See how it looks?
No, I think
This is a good one. Y equals the square root of x minus 3 plus 2. So if you switch these around, subtract 2, square both sides, I would leave that as x minus 2 squared. And then I would add 3. This is in vertex form, and we graphed these already at 3. So that's it, right there. Now, that's a parabola. We wouldn't want a parabola for the inverse, we wanted just that arc. So what would you have to do? You'd have to restrict the domain, and what would the domain restrictions be for it? It'd be x is greater than or equal to 2 and y is greater than or equal to 3. These get switched. For the next one, can I hear what you did? Can someone tell me what they did on this one? This one has 3 transformations. So what's the first thing you did? You wrote the parent function. Here's your parent function, and you should be able to do 0, 0, 1, 1, 4, 2, and 9, 3. Okay, that's good enough. What's the first operation you're gonna do?
Add 1.
Add 1 to what? You're gonna add 1. What did you get when you added 1 here?
1, 2.
And then what did you do?
Multiply the 1 by 2.
The y value gets multiplied by 2. So let's multiply these y values by 2. You get 0, 2, 4, and 6. Keep your x's the same. And then what's the last thing you're going to do?
Add 3.
You're going to add 3 to your what?
Y value.
To those y values. Adding 3, what do you get?
3, 5, 7, 9.
And did you graph this? What should it look like?
Bigger.
It's an arc.
Would it stretch?
Or stretcher.
And I got, for my graph, when I graphed them, this. Did you? And what's the domain in the range?
X is greater than or equal to
X is greater than or equal to 1, and Y is greater than or equal to
3.
3. You didn't?
I got the same chart as you did, and the graph is bigger. I go all the way to 10.
Oh, you just went, you did, you have 10-9.
Yeah.
Yeah, I didn't put 10-9. Yeah, you should have 10-9. Okay, let's put it in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So now, does that look like what you have? Okay, good. Sorry. And the last one. There's actually there's only 2 transformations. What are the 2, are you gonna do anything to the x value at all?
No.
No. But you are gonna do something to the y value. You're gonna take your y value, multiply them by -1/2. And this is also changing your y value. You're gonna add 4 to your y value. There's nothing that's done to the x. So, keeping your, did you have 0, 0, 1, 1, 4, 2, and 9, 3? The first thing you did was multiply the y values by -1. So, -1/2, sorry. So if you multiply all these y values by -1/2, you get 0, -1/2, -1, and what's this one? I didn't do this one. 1/2 would be -3/2, right? Right? -1/2. Then the only other thing you have to do is add 4 to this. So adding 4 to your y values, add 4, add 4, add 4, and add 4. What's -1.5 plus 4?
Negative 2.
2.
Yeah, 2.5.
It'd be 2.5. Okay, so we're gonna graph those points. Over 0, up 4. Over 1, up 3.5. Over 4, over 4, up 3. And then 9, 2.5. We don't have it on here, let's graph it. Let's do 9, so we have 4, 5, 6, 7, 8, 9. And then 2.5 would be right there. Are you guys with me? And it should look like, it's hard when they're small. That's what it should look like. What did you get for domain and range?
X is greater than or equal to 0.
And y is, this one's gonna be less than or equal to 4. Did you get that? Because it's up to you. Okay, now go to the next part of the notes. Does anyone know what family this is? Cube root. Does anyone know what it looks like when it's graphed?
I wanna say it's like,
I thought
An
it was
S?
a B.
no, that's absolutely,
It looks like
it's
this.
exponential.
Looks like a snake.
Oh, I was right.
Looks like a snake. X cubed looks like this, upside down. That reminds me of the John Travolta. The
Yeah.
arms are up and down. But yeah, it's a snake. She's got it. We'll add you to our picture. A snake. Danielle's gonna do the snake. Okay, so, I have a question for you. What is our domain for cube roots? What's our domain?
All real numbers.
All real numbers.
The real-
Why, Shemaya? Why is it all real numbers? What's the reason?
You can add a number to it.
Because you can take the cube root of any number. You can take the cube root of a negative and a positive. Give me the numbers that you know the cube root of so we can do our parent function. Give me a good number you know the cube root of.
27. 8.
27, okay,
Or
let's
eight.
put 27. What's the cube root of 27?
3,
8.
I heard 8. What's the cube root of 8?
2,
1.
1,
0.
0.
0, 0.
Holiday.
And then we can go the other way.
Negative 1.
-1, -8, and you could go to -27. Now, out of this list, which ones are we gonna knock off?
Like
The
-1,
27.
0, 1, and 2. Or maybe a
We're gonna cross these two out because they're off the graph. We may cross more out, but those
Cross
are
off
the,
the 8.
that's the parent function. So, the y values are also all real numbers. Let's graph this thing and see what it looks like. Over 8 down 2, and I know it's off the page, guys. 4, just make it work. 6, it's gonna be something like here, way out here. Then over 1 down 1. 0, 0, 1, 1, and then 8, 2. It's way off the page. So it looks like this. Looks like a snake. In my mind, there's your center, 0, 0. And why is this a 1? Because the cube root of 1 is 1. Why is this a -1? The cube root of -1 is -1. The cube root of 8 is 2.
Is that a
You get it?
constant type of thing? Where the
Yes,
center of that
yes.
is always gonna be 1.
Yes, but you have to watch because you're gonna have vertical stretches and
Stretches.
compressions. Okay, so now, check this out. How would you graph this cube root function? It's all messed up too, by the way. It's discombobulated. We need to know, can you fix it and write it in the correct order?
I don't really want to.
They're even asking you, can you write it in standard form? What would standard form look like?
Add 3, subtract 8.
Equals -1 half cube root x minus 2 minus 3.
Plus.
Plus 3.
Oh,
So,
whoops.
Minus 3.
now it should look clearer to you. See this right here? That's the first thing you're gonna do. You're gonna do what? You're gonna take your mother, the parent function,
No other terms.
and what is the mother function? It's y equals the cube root of x. What are the numbers we're gonna play with here? We're gonna play with -8, -1, -1, 0, 0, 1, 1, and 8, 2. We're gonna play with those 5.
Wait,
Change that.
Wait.
Negative
-2
8,
at the
negative
top
2.
for y.
Oh, I'm sorry,
Negative
-2, sorry. We're gonna play with those numbers, get in the habit of doing those 5 for this one. Now, we can do this. What's the first thing you're gonna migrate to, right here? You're gonna add 2 to the what? Okay, can I have a 2? Can you add 2 to all these for me real quick?
-6. 1, 2, 3. Right?
Uh-huh.
That's right. Add 2.
Seriously?
He added 2 to all these. What should we do with these y values?
Write 'em.
Multiply it.
Write 'em.
Just rewrite them. Be careful you don't
Oh.
do what
too
I
much
do.
at
and-
once.
So, write them again. Now, what's the next operation you're gonna do? You're gonna take your y value and you're gonna multiply it by -1/2. This affects the y value. So, I put my finger over here. How do you multiply -2 times -1/2? What do you get? What's a negative times a negative? It's a positive. What's 2 times a half? 1.
0.5.
What's the next one?
1/2.
1/2 or 0.5. What's 0 times anything? What's 1 times -1/2? And what's 2 times -1/2? What do you do with these x values?
Leave them missing.
Probably.
And then what's the last operation you're gonna do? You're gonna take your y value and you're gonna add 3. Can I get a 3 added to these y values? What do you get? 3 plus 1 is? 3.5 is? 3.5.
3.5.
3. What's 3 minus 1/2? 2.5? And what's 3 minus 1? 2. So that's what we have. No?
No.
That's
If a bird has a baby, what is it gonna be?
Could be.
Is it gonna be a frog?
No.
No, it's gonna be a bird. How do we have a parabola? If we have a snake here,
I was looking at the
guess what we're
other-
gonna have? Another snake. It's gonna look like that snake, it's gonna resemble it, but it's gonna be a little bit different. It's gonna be moved left, right, up, down, stretched. So can I get this picture? Over 6, up 4. Over 1, up 3.5. Up 3.5, thank you. Whoops. Oh, wait, that's wrong. 3.5 is right there. That's wrong. Over 2, up 3.
You're up the stream.
I'm sorry. Over 3, 2.5. And 10 is gonna be off the page, it's gonna be way off the page. But you should be able to connect these dots and make it resemble. Did you get that?
Yes.
Okay, so, we are done. We will continue on, we'll run out of time. We will continue on problem 6 tomorrow. Go ahead.